Hello, welcome to Unit 10 Review, Part 2. This one is the confidence intervals. It's the last 3 pages of your review. So let's go ahead and open to that. These are the first 3 pages, and that's on the other video, but these are all confidence intervals. Okay, so the first thing is the World Health Magazine claims that Michigan doctors recommend aspirin more than New York doctors. To test this claim, a random sample of 200 doctors obtained. Of these 100 Michigan doctors had 82 out of 100 indicated they recommended aspirin, and 75 out of 100 with New York. So I'm going to say this here is going to be a 2 proportion Z interval. We have a parameter, 2 parameters, and we have P is equal to, you could say I'll see a couple different ways you could do it. You could go P, Michigan, let's do minus New York, is equal to the true proportion.
Are we celebrating today? Are we doing anything today?
Proportion of Michigan doctors, or sorry, true proportion of doctors that recommend aspirin. And you'd put Michigan minus New York. The assumptions and conditions I have for random, I have that they're both a random sample. And then I have N Michigan equals 100, and that's bigger than 30, and N New York is equal to 100, and that's bigger than 30. And so my large sample has been, and it is a 2 proportion Z interval. Should say interval here. Okay, we're going to find this interval, and in order to find the interval, I'm going to use my calculator, and the calculator is going to be menu, stats, confidence interval, and I'm going to do a 2 proportion Z interval. So I'm going to go ahead and bring it up on my calculator. So menu, stats, interval, 2 proportion Z interval. And I'm going to go ahead and put the data in. And the data is right here, which we had 82 out of 100, and we had 75 out of 100. And I believe I asked for 95%, but just let me double check. Oh, 90%. So 90%, so 0.9. And okay. So my confidence interval is between the negative 0.02. There we go. I'm going to go ahead and put it in here. And I'm going to put negative 0.025 to positive 0.165. And so we are 90% confident that the true proportion of Michigan doctors prescribe or recommend between those are percent, so 2.5% lower because it's negative. This is negative, so it's lower, to 16.5% higher because this is positive, than New York doctors. All right, let's go to the next one. A species of fish called, yes, this is a real species, is claimed to have a different amount of spots than the panther grouper. To test this claim, I have a random sample of 32 of these, and I have an average of 45 spots, and I left out the standard deviation. So let me add the standard deviation with a standard deviation of 2.3. Let's have an average of this spots and a standard deviation of, let's give you this one, of 4.1. Created 95% confidence interval. Okay, so the parameter is going to be, I'll do P1, or sorry, not P now, because this is a hypothesis. The hypothesis interval, this is a 2 sample T interval for means. So I'm going to do mean 1 minus mean 2 is equal to the true mean difference of spots, and then I'm just going to put LX for these because it's crazy, minus Panther. Okay, and so my assumptions and condition, a random sample of both. Yes, we do, because it says we do. And large sample size, I have N is equal to 32, and that's bigger than 30. And 1, and N2 is equal to 34, and that's bigger than 30. So check here. This is a 2 sample T interval. Again, for means. And to find the interval, we're going to go ahead and use our test, and we're going to go to menu, stats, confidence interval, and it is a 2 sample T interval. And we are using, in this case, we're using stats because I have stats here. Okay, so jump over to here, menu, stats, confidence interval, 2 sample T interval, and I'm using stats, not data, stats, okay. And let's go, my X1 bar, if we remember, was 45.6. My standard deviation that I had to add to there because I forgot to give it to you was 2.3. My N1 is 32. My X2 bar is 41.5. My standard deviation is 4.1, and my N2 is going to be 34. I ask for a 95% confidence interval. I always keep cooled as no, hit OK. And this is my data. So I have my confidence interval is 2.47 to 5.73. My conclusion, we are 95% confident that the true mean difference of spots on LX is 2.47 to 5.73 more than the grouper. Okay, the last one gives us some data, so we're actually going to have to put this data in the calculator. So the way we're going to do that is this is a paired T interval. And the way we know that is because I have data that's going to be paired together. So I can put this in the calculator, or I can calculate this myself. I'm going to just do it myself. 36 minus 30 is 6. 36 minus 31 is 5. 37 minus 29 is 8. 38 minus 33 is 5. 40 minus 28 is 12. 34 minus 27 is, 7. 30, this is 3. This is 5. This is 1. And this is 4. So we're going to go ahead and put this into our calculator, and this is what gets graphed. You are welcome to put both of them in the calculator, and then you would put the difference, because this is and then you could get the same thing I'm getting. So I'm going to go ahead and do this first. Parameter is, of course, mu d is equal to the true mean difference of number of text in 1 minute. And we did quiet room minus noisy room. We have a random sample. Let's see, do we have a random sample? We don't have a random sample, so it's not stated. So we're going to proceed with caution, because we're not sure if this is going to be okay if it's not random. So since it doesn't state it's random, we have to be careful. And then my size is 10, so I have to check. So we're going to check the graph. So let's go ahead and first of all do that. So we're going to go ahead and put it into the list in spreadsheets. So I'm going to go ahead and put my data in, which is going to be, so I'm putting in the difference. Now the way I showed you in class is that you could actually put it in and let the calculator do it for you, but you can do it this way too. It doesn't matter. So if I put in, so if I do, oh, hold on. I have to type in diff sample. I just did diff sample. Okay, and then I'm going to go here. So I have 6, 5, 4, 5, 12, 7, 3, 5, 1, and 4, and I missed one of them somehow. Let's see. Oh no, I didn't. 10 of them. Okay, so I'm going to go ahead and add a page, and then I'm going to, mine was diff samp. There we go. I'm going to take a look at this, and I have, if I plot type, box plot, I've got one outlier out there, so I'm going to go ahead and state that. So I have one outlier. So again, I'm proceeding with caution. Proceeding with caution because I'm not guaranteed that my results are going to be legitimate since I do have an outlier. And this is a paired t-interval. And my degrees of freedom, remember, is n minus 1, so 10 minus 1, which is 9. So to find the interval, we're just going to go back here. All right, and we're going to open up a calculator page. Menu, stat, interval, and I'm doing a t-interval, and I'm doing data. The data is my list, and my list I call diff samp, and I'm doing a 99% for this one, and I hit OK. And then that would be my answer. So just because it doesn't meet the criteria, or we're worried about it not meeting the criteria, doesn't mean we stop. So my interval, remember, I did menu, stat, confidence interval, and I did t-interval, and then this was data. And then I used a drop-down menu to choose my data that I named. And the interval I got was 2.22 to 8.18. My conclusion is we are 99% confident that the true number text messages are 2.22 to 8.12 more in a quiet versus noisy room. But we are not convinced our results are valid because the sample had an outlier and was not random. All right, I hope that helped you, and we'll see you for the test.